Chapter 7 is going to have to do with polygons, angles of polygons, classifying polygons, so like knowing their name, finding the number of sides. We're going to learn about quadrilaterals, so that's shapes that have 4 sides. So we're going to learn about like parallelograms. We're going to learn about rectangles, squares, rhombuses. And if you're like, I learned about rectangles and squares in elementary school, you did, so you have a head start. But they have some more like properties and stuff that we're going to learn about that are a little bit more advanced. So today we start off just with basic polygons, what they are, how to identify it, how to find their angle measurements. There's going to be a lot of like calculations today, hence the calculators. But hey, proofs are over, so that's something. We have that going for us. So, trick is, how do I now get rid of this terrible menu that I do not want? There we go. All right. 7.1, angles of polygons. So we're going to start off with a little bit of vocab. First of all, what a polygon is. A polygon is a closed plane figure formed by 3 or more line segments called sides. A polygon is basically any closed shape with straight sides. Triangles are polygons, squares are polygons, octagons are polygons. Are circles polygons? No, because they don't technically have sides, right? They have like, they have like a circumference, but that's not technically a side. Yeah, it's like I was about to call it an edge, but it's not even an edge because edges are like it's like a side, they're straight. So like ovals are not polygons, right? But hexagons are, pentagons are, things like that. So right here we have a polygon. This is a 5-sided polygon, okay? But there's not like a cute little special symbol that we use for polygons like there is for triangles. We just simply would call this polygon A, B, C, D, E. And traditionally, you go in alphabetical order and you use all the vertices to name it. So like how we would say triangle ABC, right? We would call this polygon A, B, C, D, E. You don't have to name it in alphabetical order, but that's just normally the best way to do it. All right, and then in a polygon, you can have something that's called diagonals. Oops, sorry. So diagonals, that's a segment that joins 2 non-consecutive vertices. So diagonals are oftentimes drawn in your polygon to kind of split it up into smaller shapes. Like if you take a look here, we have a diagonal going from B to D and from B to E. When you draw a diagonal in a polygon, you want to pick one vertex to draw them from, and then just connect that vertex to any of the corners that it's not already connected to. You don't want to do it from multiple vertices because then won't your diagonals like crisscross, right? Kind of the point here is to take your big shape and to split it up into smaller shapes, normally triangles. If you take a look at how this polygon gets split up, don't we kind of have like a triangle up at the top and a triangle in the middle and a triangle on the bottom? Okay. So that's the purpose of that, is to kind of split it up into more manageable pieces. Okay. Then we have convex polygons and concave polygons. Convex and concave are kind of some sciencey words that you might have heard of before in a science class, like concave and convex lenses. Convex means all the corners are pointing outward, right? So convex, all your corners are pointing outward, like a very traditional shape, like a rectangle, square, etc. Concave means you have one or more vertices that are literally caving into your shape. Like if you take a look at this one here, see how this corner literally caves inward in your shape? That's what makes it concave. We really don't deal with many concave polygons, but it's just nice to know what they look like. We normally deal with convex polygons. All right. Equilateral. We've heard that word before. Remember when we talked about equilateral triangles, equiangular triangles? Anyone remember what equilateral means specifically? Yeah, that's when all the sides are really equal. Equilaterals, like equal sides. So if you have an equilateral polygon, that's just any polygon that has equal sides. So a polygon that has all sides congruent. A great example of an equilateral polygon would be like a square, right? Or actually probably the image that pops into your head for like most of the shapes. Like if I say octagon, you probably think of like a stop sign. That's technically an equilateral polygon. Then equiangular, what does that mean? The angles are all the same. And those two things normally go together, don't they? So a polygon that has all angles congruent. Again, a square would work for that. Like the traditional probably octagon shape that you think of, like a stop sign, things like that. Typically, these two things go together. I would say that a lot of like the formulas we're going to learn about today, these have to do with equilateral, equiangular polygons. Now, equilateral, equiangular is a mouthful, isn't it? I remember we struggled to say it when it was just with triangles. So when you join those two things together, equilateral and equiangular, we can simplify that, and we call those just regular polygons. Okay, so a regular polygon is a polygon that is both equiangular and equilateral. It makes it a lot easier to say. Okay, so if you, in directions, if you see, find the interior angle measure of a regular polygon, whatever kind of polygon it is, it's kind of giving you the heads up, hey, everything here is equivalent. All the sides are the same, all the angles are the same. Okay. Now we have this little table here. The purpose of this table is to kind of help us as we start to figure out some of our angle measurements. So a lot of them have formulas, but the point of this is to kind of see like why the formulas work the way they do, rather than being like, here's a formula, it's magic. I promise you that it works. Okay. Sometimes formulas do seem like magic, but I promise this actually has a reason it works. So in this table, we're just going to look at 4 different types of polygons. We're not going to like go super in depth in it. We're just going to take a look at 4 different types. We're going to talk about the sum of the interior angles. That's if you add all the little angles inside together. We're going to talk about how you would just find one of those angles, the measure of the exterior angles, and then the sum of the exterior angles. And what you're hopefully going to notice is kind of like a pattern starts to happen, and that pattern is why our formula works the way it does. That's the goal. Everything starts, though, with a triangle. It's the most basic polygon shape. We know lots about them. We spent a whole chapter talking about triangles. So a triangle has 3 sides, first of all. And then you'll notice this third column says number of triangles. What does that possibly mean? That means if I was to draw a diagonal, pick any vertex and draw a diagonal from it, how many triangles does your shape get split up into? Well, if it's a triangle and I pick a vertex, can I really draw any diagonals? Doesn't everything already connect? A triangle is a triangle is a triangle. There's just one of them, okay? You'll see more what I'm talking about in the next one. The sum of the interior angles. Who remembers that? We learned that a chapter or 2 ago. 180 degrees. So all the time, the interior angles of a triangle add to be 180. The measure of one interior angle. Now this is talking specifically about regular polygons. That means equilateral, equiangular. So who remembers if it's equilateral, equiangular? Trey? 60. If I had no idea that it was 60, if you just like, because we talked about it, right? So you probably remembered. If you didn't remember that, knowing that the sum is 180, is there a way you could figure that out? What would you do? Yeah, we could have, if we weren't sure, we could have just taken 180 divided by the number of sides. That would give us 60. So if all else fails, do that. The measure of one exterior angle. Now, exterior. Okay, so what would that look like? Well, that was when we would have our shape, right? And it would have like kind of a little like ray thing coming off of it. And exterior angle was this guy here. Doesn't seem like my Google Meet. There we go. Okay. If all of these are 60, what would the exterior angle have to be? Caden? 120. Why 120? Right. If you take a look down here, don't you have your like opposite rays type of thing going on, right? Like your straight angle. So if the interior is 60, the exterior is going to have 120. They're always going to be supplementary. Okay. And then the sum of the exterior angles, I guess I'll go back to my little janky diagram here. But imagine then if I did, oh, that erased way too much. Imagine then if I did this on all of the sides here. So this is 120. I could do it here, that's 120. I could do it here, that's 120. What would the sum of all those have to be? Trey? 360. Oh, yeah. Absolutely. There you go. Sorry, it's a really terrible drawing. Oh, no, and then it erased it again. Okay. There. Sorry. Still adjusting. New technology. Anyway, why 360? Right. Yeah. Kind of think like you're going all the way around, right? There's 3 of those exterior angles. Each one of them's 120. 120, 120, 120. That's 360. All right. So that's where you get that sum from. Again, also think about it too. If one of them's 120, there's 3 of them. You could also multiply it. Are you good with that, Gannon? Okay. All right. So now we're gonna look at this, but now with a quadrilateral. So that is a 4-sided shape. So for a 4-sided shape, if we're going to talk about the number of triangles, what you're going to do is you're going to pick a vertex, any vertex. I don't care. I'm picking the top left. And from that vertex, you are going to see how many diagonals you can draw. How many diagonals can I draw from that vertex? Just one, to like this opposite side here. Now what that does is it takes your quadrilateral and it splits it into 2 what? 2 triangles. So if you have a quadrilateral, you can split a quadrilateral into 2 triangles using diagonals. Now, why is that important? Well, that's going to help us figure out some of this other information. We know a lot about triangles, right? But we don't know that much about quadrilaterals, pentagons, hexagons, etc. Now, this next one you're probably going to know. The sum of the interior angles. What's the sum of all the angles of any 4-sided shape have to be? Does anyone know? Think about like squares, rectangles. Andrew? 360. You looked unsure there for a second. Not a trick question. Yeah, it's 360. But what if you had no idea that it was 360, right? You're like, I don't know anything about quadrilaterals. I know a triangle is 180, but I don't know what that means for a quadrilateral. Gannon? You're fine. Split it into triangles and then just add up the measures. Yeah, that's actually a really great way to think about it. You can think of it as adding, but also multiplying, right? If you know you have 2 triangles in that shape, each one of those triangles is 180. Well, isn't 2 times 180 360? Yeah. So if you can figure out the number of triangles, that's a nice, easy way to do it. Okay. Now the measure of one interior angle. The measure of one interior angle. Andrew? 90. Now 90, again, you might be like, oh, well, a rectangle, right? Rectangle, right angle is 90. What if you didn't know? What could you do with your 360 to find out that information? What could you, Divided by 4. You know that all of them all together is 360. You know there's 4 angles and 4 sides, so do 360 divided by 4. That's 90. Now, obviously, quadrilaterals are kind of easy, but this strategy is then supposed to help you when you get to like more complicated shapes. Okay, so now the measure of one exterior angle. So let's apply what we did with our triangles, Trey. Oh, you're thinking 200. That's okay. 90. It is. It's 90. Because again, think of if you took your square and you extended all those little sides out, right? I could do a little, I'm going to erase this little. If everyone was here, I would do it on the board. That's normally what I do. But if you have like a square or something and you extend all these sides out, okay, right? Each one of these is going to have to be 90 because you're going to have your straight line there. That's where that comes from. One thing, and we write it down at the bottom, so I'm not going to write it up here as well, but the interior and the exterior angle are always supplementary. So if you know one, you can find the other by subtracting from 180. Now, on to the sum of the exterior angles. Well, let's think for a second. If one exterior angle is 90, right? And then how many exterior angles would there have to be if it's a 4-sided shape? Don't overthink it. If it's a 4-sided shape, how many angles are there going to be? 4. So that's going to be 90 4 times, isn't it? So what do you think the sum of the exterior angles would have to be? 360. Oh, that's interesting. Isn't that the same that it was for a triangle? Huh, okay. It's always going to be that. So that should always be a freebie, actually, is what you're going to notice. Okay, so now we've done this for triangles. We've done this for quadrilaterals. Let's look at pentagons. So a pentagon, we're going to start the same way. Pick a vertex, any vertex, and we're going to draw a diagonal. So I'm going to pick the top just because I feel like it. Pick whatever you want. How many diagonals can I draw from here? 2. I can draw one here and one here. So that means I end up with 1, 2, 3 different triangles, right? So if I take my pentagon, which is a 5-sided shape, by the way, and I draw my diagonals in it, I could possibly split it up into 3 triangles. Okay. Well, if I know that there are 3 triangles in it, and I know that each triangle has a sum of 180, how could I use that information to figure out the sum of the interior angles of a pentagon? What could I multiply? Andrew? 3 times 180. Exactly. There are 3 triangles. I know each triangle is 180 degrees. Gannon, what's 3 times 180? 540. Exactly. So that would have a sum of 540. Now what's kind of nice is after we make this table, you can always just reference it for pentagons and hexagons, right? So that's kind of nice. Okay, so I know the sum of the interior angles is 540. All of them added together. What if I want just one? The measure of one interior angle. And people at home, remember, you're here too. I'd love to hear from you. Anyone at home think that they know how to find one interior angle if we know the sum is 540? Nobody's brave. We don't have any brave people at home today.
Divided by 5 because there's 5 angles.
Yes. Thank you, Colin. Thank you for being so brave. Take 540 divided by 5. the sum is 540, and there are going to be 5 sides, therefore 5 angles. So we would take 540 and divide it by 5, just like we did up above, right? We took 360, we divided it by 4. We take 180, we divide it by 3. So this time we take 540 and we divide it by 5, which is going to give us 108 degrees. So if you have a regular pentagon, any one of those little interior angles is 108 degrees. Okay. Now, how could I use 108 to find the measure of one of my exterior angles? What could I do? The interior and the exterior are always what? Supplementary. So if I know that they have to be supplementary and I know one's 108, how could I use that information to find my exterior angle? What could I subtract? Yeah, exactly. I could just do 180 minus 108. That's going to give me 72. Good. And then what's the sum going to be? 360. It's always 360. But if you weren't sure, in your calculators, you can always do 72 times 5. Right? 5 sides, 5 angles. So 72 times 5 is 360. Now here's another little pro tip for you, depending on what information you're given. If you want to find the measure of one exterior angle, let's just say that's all the directions said. The directions said find one exterior angle of a pentagon. Do you want to have to go through all that work every single time? I don't either. Okay? So what you could do instead is, don't we know the sum of the exteriors is always 360? Well, if the sum of the exteriors is always 360, and there are 5 of those angles, you could also take 360 and divide it by 5. And wouldn't that also give you 72? So that's just a quicker way to do that. And we outline that in the formulas down at the bottom. I just figured I'd mention that. Okay, last one, hexagons. Hexagons, this is a 6-sided shape. I'm going to pick a vertex, any vertex, to draw my diagonals from. How many diagonals can I draw here? Yeah, 3. I can draw one down here, one across, and then one to the right there. So that means I'm going to have 1, 2, 3, 4 triangles happening here. All right, so now if I know there are 4 triangles, and I know each one of those triangles is 180 degrees, how could I find my sum? Kaden? Yep, I'm going to multiply. I'm going to take 4 times 180, and you said you should get what? 720. That is exactly correct. 720. Good. If I know the sum is 720, how can I just find one? What can I do to 720 to just find one angle? Try? Divide, yeah. 720, and I should divide by what? 6, yeah. I thought you said 4 at first. Yes, divide by 6. Divide by 6 because there's 6 sides. Therefore, 6 angles, and that's going to give me 120. All right. Now, the measure of one exterior angle. Well, if my interior is 120, any ideas on what my exterior has to be? 60. 180 minus 120 is 60. And then what's the sum going to have to be? 360. Always 100% of the time, it is 360. Good. Well, exactly. And depending on the information you're given, Caden, it'll depend on which way you want to do it. but there's normally more than one good way, so definitely do the way you're comfortable. But I agree, like if I was just asked to find one exterior, I would always just do 360 divided by the number of sides. Yeah, exactly. And how you decide to do those, depending on the problem, is totally up to you. All right, so good. Now we have kind of a little basis to work with here. We've looked at some of these, so let's talk about some formulas. If I told you to find the interior angle sum of a 25-sided shape, do you guys want to sit there, draw the shape, figure out the number of diagonals, then split that up into triangles, and then multiply it? I was like, no, I don't either. I don't want to grade your work for that. That sounds terrible. So we need an easier way to do it, and there is a formula. How'd you get that? The number of sides by 360. I like what your number of sides by 360. Well, there will be some multiplication in there. We don't have to multiply by 360 though. That'll give us some real big numbers. Take a look at your table. What do you guys notice about the number of sides versus the number of triangles? It's always 2 less. And then once we found the number of triangles, what could we do to it? To find the sum. What did we always multiply it by? No, not the number of sides. Take a look at the sum column. Took the number of triangles and multiplied that by what number, though? 180. So if the number of triangles is always 2 less, do you have to sit there and draw it each time and put the diagonals in and count the number of triangles? No, it's always just 2 less. And then you multiply by 180. So that's actually basically your formula to find the sum. And these are important formulas that you don't have to memorize, but you have to know the appropriate place to use which one. And there might be some other ways to do things that aren't necessarily formula based, like, you know, you might see something and like want to work backwards in some way, right? So these are just some suggestions for you. So the sum of the interior angles, you find that by doing n minus 2, where n stands for the number of sides. So maybe make a note to yourself, n equals number of sides. So you take n minus 2 times 180, and you're going to use that formula a lot. N minus 2 times 180. I'm sorry? No, that's just the way you'll see it written a lot. I don't care what letter you use. Sure. Now, just keep in, there's going to be other things I use an X for, so don't let yourself get confused. Okay, to find one interior angle, once you have the sum, can't you just divide it? So this one, so I'm just going to go ahead and tell you right now, this is not a formula that on like a test or quiz, it'll necessarily be like written out for you. But I wanted to like show you in a formula type format how to do this. You just take your formula up above and divide it by the number of sides. That's all that is. So you take your n minus 2 times 180, because that's your sum, and you just divide it by the number of sides. Again, heads up, that's not a formula that's normally provided for you. That's something I expect you to be able to be like, oh, now I know the sum, and I can divide. I just took the original one, Caden, and divided it by the number of sides. I will tell you, though, that on a test or quiz, this formula is given to you. The sum formula is given. And then a lot of it we expect you to be able to, like, figure out based on that. Okay, what if you wanted to find the number of sides given one interior angle? Okay, now this, there is more than one way to do this. This formula is gonna be like a suggestion. Okay, if you want to find the number of sides given one interior angle, there's a whole long process that you could possibly go through where you take your one angle and you try to figure out your sum based on that, and then you kind of like go through your formulas. It's kind of a pain in the butt though, and it takes a while. The easiest way is you actually use the sum of your exterior angles. Because isn't the sum of your exterior angles always the same no matter what shape it is? That's what's nice about it. It's consistent. So what we do is we take the sum of the exteriors, which is 360, and we divide it by, we actually divide it by an exterior angle. But you don't know the exterior angle, you know the interior. Once you know the interior, you can find the exterior by subtracting from 180, right? So what you actually do is you do 360 divided by 180 minus x, where x is your angle. Okay, x is like your degrees that you're given. So if it helps you can put like a little degree symbol. Again, this is just one strategy. There might be if you're doing it and you're like, oh, I want to do it this way instead, go for it. I don't care. As long as it works all the time. Okay. Sum of the exterior angles. What's always the sum of the exterior angles? All the time, it is always 360, exactly. To find one exterior angle, well, if you know the sum, take the sum and divide it by the number of sides or the number of angles. So you can take 360 divided by n, your number of sides. And then to find the number of sides given one exterior angle, it's actually almost the exact same formula. Because you know the sum is 360, right? And if you know one angle, you can take 360 and divide it by that angle. So that formula can almost work for more than one thing. It's just depending on what you're dividing it by. So to find your angle, take 360 divided by the number of sides. To find your number of sides, take 360 divided by the one angle. So it kind of works because you're splitting it up into equal parts each time. And then last thing at this, the exterior angle and its corresponding interior angle are always supplementary. Okay. If my memory serves me right, typically the information we'll give you is the sum of the interiors, the sum of the exteriors, the number of sides given one interior, and the number of sides given one exterior. I think those are the ones that are normally like given to you on a test or quiz. Okay? All right. So we are on the back. Okay, so now is going to be, you might need to flip back and forth a little bit in this to look at your formulas and stuff, okay, because this is now going to be applying these. I tried to make sure I included everything you will see on your homework. Okay, so your homework will be on the next page. All right, so examples, make sure you read carefully and use the proper formula. You'll notice there's a little chart here on the right. This chart is to help you with maybe some of the less familiar quadrilateral names. Like I think we should probably know up to at least hexagon, right? That's 6. But you might not have heard of a 7-sided one before. That is a heptagon. Sometimes, occasionally, depending on the book, it's called a septagon, but we don't really use that. We use heptagon for 7. Octagon is 8. A 9-sided is a nonagon. I kind of like that one because it kind of sounds like 9. Nonagon, 9. 10 is a decagon, and 12 is a dodecagon. Okay. Those ones are sometimes confused, so I would just make sure that, you can write that down somewhere else if you want, or make sure you know where to find this. So the unfamiliar ones, 7 is heptagon, 10 is decagon, or I'm sorry, 9 is nonagon, 10 is decagon, 12 is dodecagon. Anything else that's not on that list, it has a name technically, but they're like things we would never remember in a million years, right? They're not really commonly used. So anything that's not on that list, we just call it the number of sides and then gone. So like a 15 gone, a 20 gone, a 30 gone. It just makes life a little bit easier. So we're not remembering 1,000 different names for polygons. All right, so first thing we are going to do is find the sum of the measures of the interior angles of a decagon. So if you take a look at your chart here, a decagon means we are dealing with a 10-sided shape. Now, with these, you really got to look for your context clues. What is this problem asking me to find? Well, it says, first of all, to find the sum, right, of the measures of the interior angles. So the sum of the measures of the interior angles. So if you take a look at the front of your notes, is there a formula for this? To find the sum of the measures of the interior angles. People at home, don't be afraid to chime in as well. Any ideas? The sum of the measures. It's the first one on the list. Here, let's scroll back up. Does one of these say the sum of the interior angles? Thank you, Austin. Yeah, n minus 2 times 180, sum of the interior angles. So if you're ever asked to find the sum of the interior angles, you're going to use n minus 2 times 180. So then we're just going to plug our 10 in here. And on a tester quiz, how you show work for this is kind of up to you. I would hope that we all know how to subtract 10 minus 2, right? So if you want to plug it into the original and show like the full 10 minus 2 times 180, that's cool. Or if you do like 8 times 180, like in your written work, I would understand that as well. Okay, so 10, like you don't have to necessarily show out 10 minus 2 times 180 equals 8 times 180 equals. It's up to you how much of that you want to show. But it would become 8 times 180, which is 1,440 degrees. Okay, and you can do that for any shape, really, okay? So we're actually going to come back to 2 because 2 is one I'm going to ask you to try out on your own in a second. Number 3, the sum of the measures of the interior angles of a convex polygon is 3,060. Classify the polygon by the number of sides. That means, hey, figure out the number of sides. So let's see what we're given here. First of all, we're being asked to classify by the number of sides, aka find the number of sides. But what information are we given? Well, we are given that the sum of the measures of the interior angles is 360. Well, let's just look and see if we have a formula. Okay, so classify by the number of sides. Well, I see 2 that have to do with the number of sides. It says the third one down, find the number of sides given one interior angle. Are we? No, we're given the sum, right? And then we also have find the number of sides. This is the second to last one. Find the number of sides given one exterior angle. We weren't given that either. We were given the sum of the interior angles. And I'm going to use that to find the number of sides. Now this, we actually have a formula for it already. You just don't know it because we're using a formula a slightly different way. Don't we have a formula for finding the sum of the interior angles, Trey?
Degree, 3060 divided by 180.
Yeah, and then last step is you also have to then add 2. What we're basically doing is working backwards from our first formula. We can find the sum by doing n minus 2 times 180, but what if you already have the sum? Then work backwards. And I don't care how you write that out. I just to show you guys how we're doing it, I'm going to write out the formula and work backwards from that. So technically what we're doing here is we're taking our n minus 2 times 180 formula and we're working backwards from it. We know our sum is 3,060. Right? Our sum formula, we know it equals that. So now we're going to work backwards from it. And again, if you want to just work backwards with just the algebra part, that's totally fine. But when you work backwards here, we're going to divide both sides by 180. That's going to give us n minus 2 equals 17. And then you're going to add your 2 to both sides, and you're going to get that n is 19. So you might just be asked, what are the number of sides? 19. Or if you want to get technical with it, it is a 19-gon. Is technically what that would be called. Okay. So same formula used in a slightly different way. All right, actually, before we go on any further, I want you to go back and try out number 2. So number 2 just says find the sum of the measures of the interior angles of a 16-gon. So that's just what formula do I apply? How do I apply it? So take a second if you haven't done that one yet. Try it out. And heads up, I'm going to call on somebody at home. So we've been very quiet. So get ready, remote learners. Okay. Rosalind, what do you think you would do to solve for number 2?
I would use the same formula that I did for number 1.
Yeah, good. So what should I write?
16 minus 2 times 180.
Yeah, good. Yeah, we're just going to apply our n minus 2 times 180 formula again. So 16 minus 2 times 180. And Rosalind, what'd you get for your sum?
2,520.
Good, 2,520. Good. That's a very common question. Just like heads up, that one's going to happen a lot. All right, number 4. Find the measure of each interior angle and each exterior angle of a regular 24-gon. Each means 1, okay? So if I want you to find the measure of each, that means just find one of them because they're all the same, okay? Now this is a perfect example of there is more than one good way to do this problem. If you want to find each interior, we could find the sum first, right? Do our n minus 2 times 180 formula. That would give us our interior angles. Okay, so that's one way to do this. That's what we'll do. And then keep in mind, think about like, is there a different way to do it? And just, I'm curious if anyone sees a different way. So we are going to start with our interior angles. So I'll label here. We're going to find our sum first. So we're going to do our n minus 2 times 180 first. That's going to give us 24 minus 2 times 180. That's going to give us 22 times 180, which is 3,960. So that's the sum. So once I have the sum, who can remind us how to use the sum to find one interior? What would I do? If I have the sum, how can I now find one interior? I got to do something to 3,960. Trey? Yeah, divide it by the number of sides. If that's everything put together, I want to find out what is, think about it split into 24 equal parts. So I would do 3,960 divided by 4, which should give you 165 degrees. Now let's see if we remember. Oh, I don't want to do that. Let's see if we remember, if I have an interior, how can I then use that to find an exterior? The interior and the exterior are always what? Supplementary. So what could I subtract from? 180. Yeah, I could just minus 165, and I'm going to get 15 degrees. Good. Now this is just one way to do it. Can anyone think of a different way? Tyler?
I started off by finding the exterior angle, so I did 360 divided by 24.
Good.
15, and then I did 180.
Perfect. That is exactly the other way you can do it. Now, for that way, that's actually a quicker way. Personal opinion, it's an easier way. It's a quicker way. I tend to show this way because people like to go in the order thing you're asked for, right? And I know that a lot of people would be like, oh, well, I have to find the interior angle first. You don't have to, right? Tyler found the exterior angle first by doing 360 divided by 24. That's fine, Natalie. You're okay. No worries. 360 divided by the number of sides, right? So he found 15 first, and then do 180 minus 15. That's a good way to do it as well. Do what you're comfortable with. All right, number 5. Each exterior angle of a regular polygon has a measure of 18. Find the number of sides. Each exterior angle has a measure of 18. Find the number of sides. Well, let's look up at our formulas. Find the number of sides given one exterior angle. We have a formula for it. Let's use it. Now, key thing here is, because if you're like, well, what if I'm doing it on my own? Look for your keywords. You're given an exterior angle of 18, right? So think, oh, I'm given an exterior angle. I'm probably going to have to do something with 360. So you have 360 degrees in total. If each one's 18, you can just do 360 by 18. Because each little piece is 18. This is just going to kind of show you how many pieces there are. And Gannon, tell me what you get.
I got
20. Sounds good to me. So we can say 20 sides. You could say 20 gone if you wanted to. 20 sides is easy though. Okay. And then each interior angle of a regular polygon has a measure of 140. Find the number of sides. Let's see, is there a formula for it? Find the number of sides given one interior angle. There is. Now, here's kind of the other nice thing about these formulas. You don't have to really use them as a formula. Think of them as like a suggestion of steps. Okay? If you know an interior angle, can you find an exterior angle? Yeah, subtract by 180, right? If you know the exterior angle, can you just then do 360 divided by it? Yeah, this is just written all kind of as one big step, but you don't have to do it as one big step. Go back down there. So number 6, it's telling you each interior angle has a measure of 140. So one way to do this is to use your 360 divided by 180 minus x formula, which is 360 divided by 180 minus 140. Now, the whole purpose of this 180 minus 140 business is to find your other angle, like your exterior angle, okay? So if your interior angle is 140, isn't your exterior angle just 40, right? 180 minus 140. So 360 divided by 40 would be 9. So 9 sides. So again, the formula is just like a suggestion of steps you should take. You don't have to necessarily use it in that exact context. I personally think it would even look easier to just do, okay, 180 minus 140, and then take 360 divided by 40. You can do it as like two completely separate steps. Any questions or concerns through 6? You good, Abby? Okay. Did we get this all down? Okay. All right. So now exercises 6 through 9, find the value of x. We've actually done problems really, really similar to this before, just with triangles. So before, if I gave you the diagram of a triangle and it had all 3 angles labeled and I asked you to solve for x, wouldn't you just do one angle plus the other angle plus the other angle equals 180? This is the exact same thing, except this isn't going to equal 180 on what kind of shape it is. Okay, so maybe if it's a 4-sided shape, it'll equal 360. If it's a 5-sided shape, it'll equal 540, right? And so on. So this is a 1, 2, 3-sided shape, which this is always a nice thing to look at our handy dandy table for if you really wanted to. A 5-sided shape is going to have a sum of 540, or if you don't know, just use your formula, okay? But I don't normally give you anything too crazy. So what we're going to do is take our angles and add them up and set them equal to 540. Now, if you're someone who likes to kind of go through and subtract what you have first, like that's totally fine. I don't really care how you solve it, as long as you find it in a reasonable manner that works all the time. So what I'm going to do here is I'm going to take x plus 122 plus 100 plus 90, because we have our right angle box over here, plus 144 equals 540, because this is a 5-sided shape. Okay. Then I'm going to combine my like terms. I'm going to get x plus, thankfully I already have this all worked out here, 456 is what you should get. Please tell me if you think I'm incorrect, because I'm looking at my numbers from last year. Can you read it, Caden? Uh-oh. It says x plus 456 equals 540. And now I'm going to subtract. That's okay. You do it a different way. And then I'm going to subtract, and regardless of what way you do it, you should get 84. Cool. Okay. You didn't have to do it like this. You could have gone ahead and added up all the angles to begin with, right, and subtracted it right away. I'm guessing that's how you did it. Yeah. That's totally fine. This is just me showing you kind of like the most generic way to do it. Are we okay with that? Okay. So now take a look at number 7. How many sides do we have here? 5. What's the sum of 5-sided shape going to have to be? Trey? 540. So we're going to do the same thing. I'm going to add everybody up. I'm going to set it equal to 5. So that's going to be x plus 2x plus 84 50 plus 102 equals 540. And I trust that we can all add and subtract and divide by 3. And when you do all that, which I'm going to let you do on your own time if you'd like, just because I want to get through this, is, I don't know, I don't have this one worked out. I lied to you. What is it? 68. Did the rest of us get 68 as well? Sounds great. Sounds about right. Let me know if you don't get 68. I'm going to trust Caden and Gannon's math. Do we feel okay about ones like that? Okay. For some reason, occasionally ones like that throw people. I think they just look at it and there's a lot going on. They're like, I don't know what to do with it. Think of it just like the triangle problems. Add everybody up. Now, what's different about 8 and 9? Here, I'll zoom out in case anyone.
Yeah.
Exactly. 8 and 9 are dealing with exterior angles. Now, here's what's kind of nice about this. The sum of the exterior angles is always what number? 360. So do you even have to put that much thought into what the sum is? No. These ones, it's the exact same idea. Add everybody up. and set it equal to 360 because they are exterior angles. So you can even make a note to yourself here. These are exterior angles. So exterior angles have a sum of 360. So that's all the time if you see a picture like this. So here we're going to add everybody up. I don't want to write down all those x's, so I'm going to put up my x's here. We got 1, 2, 3, 4, 5, 6 x's. So 6x plus 30 equals 360. We good? I'm going to subtract my 30 over. 6x equals 330. And I'm going to divide to get 55. We cool with that? Yes? Okay. People at home, are we okay so far?
Yeah.
Yeah.
Excellent. All right, and then last one of these, number 9. Oops, number 9 is the same thing, so we're just going to do what we did before, set it up, and then I trust that we can subtract and divide. So here, same idea, add everybody up, and since they're exterior angles, we're going to set it equal to what? 360. Thank you, Gannon. So x, and I don't care what order you write these in, okay? You want to like pick a spot and then go around, go for it. You want to write all your x's first, go for it. I don't care. So I'm going to say that this is x plus, and then I'm going to put in my angles, 70, 86, and 92, 360. Okay, but however floats your boat. I don't really care. At the end of the day, though, you should get a number. Let's see what that number is. 70 plus 86 plus 92. So when you add everybody up and subtract from 360, you should get 112. And then divide that by 2. Ooh, that's not what that is. So you should get 112 divided by 2 is 56. Does that sound right? If we did it? Yeah? Okay, cool. Always check. Because I type stupid things into my calculator occasionally because I'm a human being. All right, and then last thing, real quick. This is the exact same thing, just slightly different picture. Find the measures of x and y. Now, all it's really telling you in this picture is, well, number one, we have a four-sided shape. So we know all the angles are going to add to be what? That's three-sided shape. Four-sided shape is 360, and we know that x and y are the same. This is the exact same thing, except it's like a make-your-own formula type of problem. We have no idea what x and y are, so could we assign a variable to them if we wanted to? Sure. If assign them a variable. You could call it x if you want, or a, or g, or b, or I don't care. If x confuses you because there's already an angle x, pick something else. So could we then, from this point, do the exact same thing we did up above? Sure, you could. Does anyone have another way, though, that we could do this that does not require a formula? No? You don't already have a strategy, Kaden? I'm shocked. Uh-oh. Well, it's a four-sided shape, which means its sum is going to be 360, right? And don't we already have a 102-degree and a 90-degree angle? Okay. So that means if we take 360 and we subtract what we have so far, which is 90 and 120, we're going to get 360. Let's see. 360 minus, what'd you say? Yes, it would be 150. Oh, that's a great question. Once I find 150, what can I do to 150 to figure out what angle x and y are if they're congruent? Trey? Divided by 2. They're equivalent, right? Oh, yeah, they have the little arcs. Right? X and y are marked as congruent, so then what you can just do is take that, split it in half, and each one should be 75. So the measure of angle x and the measure of angle y equal 75. That's just one way. You could if you prefer, if you're a formula type of person, then do a formula, right? X plus 120 plus 90. Whatever you like better. Oh yeah, I can talk. You're good. Okay, so number 11 is the exact same idea. X and Y are the same thing, right? How can I tell they're the same? How can I tell they're congruent? The little arcs, right? So I can do the same thing here. This is a 1, 2, 3, 4, 5, 6-sided shape. So you could either go up to your chart, or 6 minus 2 times 180 is 720. So you can do 720 minus what we have so far, which is a lot. 108, 103, 149, and don't forget your right angle. Subtract that and then divide by 2. Sorry, I thought we'd get done early, but it took a lot longer than I thought it would.
We are aware of the Canvas issue that is affecting all students with new courses or teachers.
There we go. That answers question.
And know that we are working on a solution. Scheduling for the
So this should give you 271. Does that sound right? Did you guys get a decimal for this one? What did I plug in wrong? 120, 103, I did 148 instead of 149. Yeah, so this should be 270, and divide your 270 by 2. Uh-oh. That's okay. So you should get 135. Okay. If you don't have any questions and you're good to go, Jacob, they were just talking about the Canvas issue, so once that's taken care of, I'll make sure that you know where to find everything, okay? But anyway, people at home, 7-1 worksheet is your homework. That is due on Thursday. It's the same thing for you guys. 7-1 homework is due on Thursday. I will walk around and check your worksheet. If you're remote, submit it on Canvas. Have a lovely day, and we'll keep an eye on that Canvas thing, okay? Bye, guys. Have a great day.
Have a good day.
Thanks, Jacob. Nice to meet you. Have a good day. Bye. Have a good day. Sorry, what happened? No, you're totally fine. Yeah. Bye, Megan. Nice to meet you. Oh, and perfect. Thanks, Megan. We'll keep an eye on the Canvas thing. It shouldn't be a big deal until, like, when we have an e-learning day or something. Bye. Oh no, so it's all messed up.
Right, and then I have psychology, nutrition, wellness tomorrow, but since it's a full day, e-learning, I won't see any teachers, and I'm not in any of that either.
Oh no.
So,
I wonder if maybe, do you have an SRT next block?
I have it 6 blocks.
Oh, I was gonna say maybe if you had SRT, you could go at least like try to hunt down your teachers.
Yeah.
I would just email them.
Okay.
Send them an email, be like, hey, I can't get into your course. Is there a link I need for tomorrow or a worksheet I need or something?
Okay.
I'm sure that people, hopefully it'll be fixed by tomorrow,
Yeah.
but hopefully people will be flexible. Have a nice day. Bye. Not really. Yeah. Hello. Oh, by the way, guys, if you want a new seat, pick a new seat. I don't care. Go for it. Anywhere you want. So, but I figured we'd have a few new people. What's your name, hon? Because I don't think, have we met before? What's your name? Sarah. Okay. I will probably ask you again when I write down the seating chart. SRT rules are pretty simple. Pretty much be quiet. You're welcome to, if you need to go see a teacher, just make sure you have a pass or like something, they email me, whatever it is. Obviously, I highly recommend you work on homework, but if you don't have anything to work on, I don't mind if you listen to music or go on your phone or whatever that is. As far as the restroom and stuff goes, I'm not super strict about it because it's right around the corner. So if you need to go, just let me know. Don't disappear. Because then, we actually, I think our SRT's actually been really good this year.
Yeah, there's it's just generally very quiet.
It's very quiet. I haven't had anyone just yeah, just like disappear yet. Pretty much every year I always at least have like one person, I'm like, oh, they've just like left and have not come back, but not this year.
Miss Dyer, I think Kate is coming in today.
She is. Kira came and got fast for me. If you want a new seat, you guys can pick a new seat if you want. It's totally up to you, wherever you want. Go for it. You're welcome to pick the same seat if you want. I just figure we'll probably have some switches from remote to in person, so wherever you would like to be is fine. Hello, hello, if you'd like a new seat, you can pick one. If you'd like a new seat, you can pick one. Where are you going today, my dear?
Carden.
Carden. Do you have a pass? No, I'll just write you a hall pass just in case, okay? Are you gonna be there all block?
Probably.
Okay. If that changes and you go somewhere else, just please let me know.
A-T.
M-A-T.
E-L-Y-N.
E-L-Y-N. I knew it was a weird one. Okay, to Garden. 11:05. And I'll probably, when we get the new seating chart up, I'll just throw you in a seat. So that's on, because you're never in here anyway, right? Oh, okay. Pick a seat, any seat. Go for it. Jesse, right?
Yeah.
Okay. Sorry, I like totally like malfunctioned for a second. Pick a seat, any seat. If you want to switch, Scott, you can. It's up to you. Have a lovely day.
Hi, Modesty, please come to the nurse's office. Hi, Modesty, please come to the nurse's office.
Faith, you were in here at the start of the year, weren't you? You were in here at the start of the year, weren't you? Okay, so you know the drill. Okay. Hello. Oh, hi. Welcome. Yeah, I was about to tell you can pick any seat. And I was about to ask you your name, and then I looked at you. How are you? I am well. You haven't been in my SIT before, have you, Jeremy? General rules, it's pretty basic. If you need to go somewhere, just make sure you either have a pass or like they email me or just like something, you know. You're back.
He's not in there.
Oh, okay. He'll probably be back soon. Hello. You're leaving again. Yep. You're pretty much gonna leave. Hello. Pick any seat, okay? And that will be your seat for the time being. Give me 1 second. Yes. Yeah, we had a lot of switches from remote to in person. You're pretty much gonna go to your mom's every day, right? Yeah. I'm just gonna assign you then like a generic seat. Okay. Okay. Thank you. Bye bye. General rules. So like, what's your name? I'm sorry. Bree. Okay. Bree, Jeremy. If you need to go see a teacher or something, just make sure you have a pass. They email me or whatever. Welcome. It wasn't this full last semester. If you're welcome to listen to music. I don't care really if you go on your phone or whatever. Obviously, it's your homework, so it's your problem. And then, yeah, and just keeping it quiet is really like the big thing, just because I'm doing work. I have people coming in doing work. People, so just be respectful. We'll be fine. Don't disappear anywhere. Hi. Did you have to go up those stairs? Oh yeah, that's exhausting.
I was running.
Oh, don't do that. Oh my gosh, I'm still in this Google Meet. Hold on. What? I'm still in my old Google Meet that no one's in anymore. How's it going? How's life? How are things? Yeah.